working at SinterCast for some time now. So Arnaud got his Foundry certificate in 2005 from Loris Nancy. Then he made his Master of Metallurgy and Master degree in Physics and Materials at the University of Nancy. Then he had a 2-year experience working in the well-known cookware company Le Creuset in France as metallurgist and quality control. And then in 2010, he moved to SinterCast, where he is chef engineer on tracking technologies. He's the one behind the maintenance and development of the SinterCast tracking technologies. Is also experienced in cast iron solidification and process control for compacted graphite iron. And he has the privilege of traveling a lot around the world, where he goes to Brazil, Mexico, the United States, Canada, Asia, India, Germany, Italy, Sweden, and the UK. So I asked Arnaud where he finds the time to ride the bicycle that he so much loves. And with Arnaud, we will have Luís Guedes. Luís Guedes works at Tupy. He is a graduate in Foundry engineering and started his career in 2008 as a trainee researcher at SinterCast in Katrineholm, Sweden. Afterwards, he also had a trainee experience in the melting area at the Tupy Foundry in Joinville, Brazil. After that period, he worked as a metallurgical engineer with CGI process at for 2 years, then left the cast iron foundry and joined for 7 years family foundry on non-ferrous alloys, and then went back again in 2017 to Tupy Joinville in Brazil, where he works as product development and quality specialist. At the moment, is at Tupy in Saltillo in Mexico and is responsible for CGI and gray iron process. So we have here 2 experts on CGI and process control that will lead us through and Industry 4.0 process applied at the Tupy Foundry in Mexico. So Arnaud and Luís, it's a pleasure to have you guys with us, and you can start your presentation.
Thanks, Victor, and good afternoon, everyone from Sweden. So you might know about SinterCast for compacted graphite iron and engine applications. But over the last years, we also use our experience in Foundry and process control to develop 2 new technologies for adaptability, which I will introduce in the first part of the presentation. And in the second part, Fernando Guedes from Tupy will talk about the benefits observed from this technology at the Tupy Foundry in Mexico. So I will start to present our ladle tracker technology, and I would like to do that with reference to our installation at the Tupy Foundry in Mexico, running since January. So on this schematic picture, we can see that the process, the process flow of the line where the ladle tracker system is installed. The iron can be tapped from any of the 3 furnaces hidden in the bottom part of the picture. Then the ladles are transferred to any of the 3 treatment stations, and then to this platform where they control the chemistry and the temperature before going to one of the 2 point cars. So in total, at that line, there are 9 ladle tracker positions. Next slide is showing a typical ladle tracker position. So the ladle tracker uses RFID technology, which stands for radio frequency identification. And we can see on that picture or on that position the RFID tag placed on the ladle, which is read by a RFID antenna, which is connected to RFID reader, which communicates to the main computer via Ethernet. So each tag is programmed with a unique number, and the radio frequency signal of the antenna is calibrated at each position in order to optimize the reading range according to the distance between the RFID tag and the RFID antenna, but also to avoid any interference with ladles around in the process. A signal used like at Tupy to log the process and prevent pouring bad ladles which present a parameter outside the limits, the process limits. So then, after that, SinterCast continued to expand the tracking technologies to track and trace the cores, the core packages, the molds, and the castings. So I like to start with the creation of the future marking on the casting, which can be done on the core or directly in the green sand mold. But again, I would like to use our cast tracker reference installation at Tupy, Mexico, to explain the different steps of this technology. So here, the future casting is engraved on a separate core, which is inserted in the core packages. On the outside of the core package, a data matrix label is affixed, which this data matrix code contains the same ID as a future casting marking, as a future casting marking of the casting. So I just want to show a short video of the engraving station. Give you a feeling. So around 1 second per digit. So then the data matrix level is scanned at any steps of the course, of the core process until the molding line. And also allows the operator to check the storage time of the core before putting it into the mold. At core setting, the data matrix information is transposed to the RFID tag of the flask. So has its own RFID tag, and any time that a flask moves to the line and passes in front of an antenna, we can identify the time and the identity of the components inside the mold to track, for example, line stoppage, but also how long molds were made before pouring and how long the casting stayed in the mold before checkout. At pouring, we make a handshake with the ladle tracker system and combine the metal history from the ladle to the core and the molding history from the flask. And all data are collected in one single database where every casting has a row with all his production history. Then, after checkout and cleaning the castings, before, during control, and each casting number are read automatically, by an OCR system and associated to the control result, either input automatically by the ultrasound device or manually on the touchscreen by the operator to indicate if the castings are defect or not, and in that case of defect, which defect type and the location of the defect, which again is collected in the same database. Luis, I give you the relay.
Okay, good morning from Mexico. I'm very glad to work with the tracking technologies here in Mexico. Here as a process engineer, you know how important it is to have a good data to analyze, and sometimes timing to have a fast answer is always very important for a customer internally to have a casting defect control, and we know how important this is for an engineer. Here in Mexico, in Tupy Saltillo, we have 3 pouring lines, and in one line we are using the tracking technologies, and in the other 2 lines we use the old normal production control with paper record. That here we see a lot of different manual notes doing by operators in a line that we don't have the tracking technology. We need at least 5 operators to doing all the records and to have all the data, temperature measurements, pouring time, casting ID sequence. So all manually, differently from with the cast tracker, that we can have everything together in an Excel file that as I mentioned, timing is very important in this for this. And here, for example, with a data record that we have with the tracking technologies, we can find all the core IDs for the all core packages that we produced, and then here we have the starting time, what time we have the molding, what time we have, what time and shift we assembled the cores in the molding line. We know all the melting numbers correlated with the casting ID from the cast tracker. We have all the flask position. If we from the ladles, each ladle also we have the what pouring station. For example, we pour in line 3 with 2 pouring cars. We can check also if the casting was poured in car number 1, car number 2. We can see in a defect if the core package was in the position 1 or 2. We can check all the temperature, timing, all the ladle treatment results from like a CGI process, as a modification, inoculation, how much wire was injected in the ladle, the carbon equivalent, all the data that we need, at least 5, 6 papers, and we take more than an hour just to try to analyze a data for a casting defect. Here with the tracking technologies, we can find this in 15 minutes. So we have all together. This makes things much easier for engineer to work. And this one is other good data that we have from the system, that is to that we can use to improve our process, as like to identify where and why the ladles were dropped out of the process. If you are losing time with the control of the chemical composition of the furnace, or if we have more problems with temperature control, or if we have problems with like modification, or all the problems that we can have in the process, we can identify here with this report. Also, we can check with the team in what shift we're having more problems compared to others, and we know that it's like for us in line 3 that we work with CDI control. We know that is a lot of variabilities to have a good process, and this depends on a team. So depending on the shift, sometimes we have different problems that we can work with the team to set and measure all the KPIs that we have in the process with this report. So here is another good thing about the tracking technologies is the process quality. Here we can have all a good correlation between the microstructure results and the casting defects. All the ladles we can have the microstructure, and we can find, like based on the last report that we showed with the Excel file, we can see what was the melt ID, and based on the melt ID we can check how was the microstructure, and we know for like a CGI process how the microstructure is so important. We can check the nodularity, the graphite shape, if you have any kind of problems, any excess of nodular flake patch in this ladle, we can improve our quarantine control, and also we can use all this data to check and to have a good results from customer returns or any internal trials. And so this is all together in the system that help us to have a good control, metallurgical control of each ladle. 100% of the ladles we have the microstructure controlled. Here is one example of like a cast ID. If I find, like, if I have for example, shrinkage or gas porosity detected in the customer or internally, if we segregated some batch of production or some trials, we can check by the cast ID, and we can check in the system what was for example, this one was 04E00D. It was the second. It was the first mode of a ladle. The position, we can see the position of the core. What was the pouring temperature? What time was this melt being poured? What shift? How was the pouring duration? And I can also check if I had any of sand inclusion or any other kind of gas. We can check also how was the core storage time, and what date and when all the core were produced, besides of the pouring history. So this is so much fast for us to do a good to have a good traceability of our process. The process control, one of the most important things that we have in a Foundry. We use the tracking system to improve this, to approve only good ladles. So all the ladles, if they are out of our range of our process specifications, the system blocks the ladle. So if you have any difference of measurement of weight of the metal inside the ladle, the treatment is not accepting this ladle, it blocked. So the same for a temperature-based treatment. or in the pouring station, if it's out of the range in the base treatment, or the pouring temperature is out of specification, the system blocks this ladle. This can't go for the next station. So this is a very important thing that we have, because the decision is not in the operator's hand. So we know what are our variabilities on the system is doing the job. So this is a very important thing, especially for like a CGI process, that we can just comparing, like we have two different lines, one with the tracking technologies, another without. So because we never know what happens during a third shift, or sometime that we are not inspecting or doing auditing the line. So the system is doing this job for us. So it's very helpful.
One of the other benefits is to investigate on refractory performance. So today at the Foundry, the operators look at the ladle for refractory wear and decide when to send it for relining. But with the ladle tracker system, we know how many days it has been since the last relining. We know how many times and how many minutes the ladles have seen liquid iron. So the Foundry can develop rules to optimize the relining process. So working in a Foundry, small experience. I've been in every morning in the production meeting to review yesterday data. And when there is a problem, everyone is pointing the department or the other, core shop, Foundry point core shop. Here you can get all data, reliable data automatically. As I said, Luis, takes a few minutes to download the report. And the beauty of it also is that both systems, the ladle and cast tracker, are adaptable to each customer need. So some foundries are already collecting a certain amount of data, and SinterCast tracking technologies can also be installed to acquire only the missing data, like it was in Scania, for example. The data are displayed in real time on any device connected to the Foundry network, such as a mobile phone. And the data are grouped in a SQL database and can be transferred to the Foundry ERP system. Thanks, Victor, for the invitation and listening us.
Thank you so much for your presentation to both, to Arnaud and Louis. So we have here a question from André Ribeiro from Continental. He's making two questions at the same time. So he's asking, why was the system applied to one out of the three lines that you have in Mexico? And the other question is, can all the trackers or devices survive the harsh environment of a foundry? And are there any special measures taken to assure this method is robust?
I can start answering the first one. We have in line 3 the tracking technologies, because it was the first one. I hope it's not the last one. So for me as an engineer, I would love to have the tracking technologies in all lines. So we started with this one, and we hope in the future we will have the tracking in the all lines that we can have. Don't know if Arnaud can complement. Yes.
Of the equipment, of course, we are always choosing the robust parts, components on the market, and we are customizing to survive in Foundry environment, but also now we started with steel industry, which is even more harsh. And then the third question.
It was that if there is any special measures taken to ensure that the system is robust physically, and the other one was why do we install it only at one of the lines from Tupy in Mexico that Luis answered, as it is the first prototype line in which you are doing the implementation of this, and the wish that it escalates to the other two lines.
Yeah, and maybe Luis, Victor, if I can add that.
Yeah, yes, sure.
Some data. The Ladle tracker system is running since January 2015, so tracking around 15 ladles per hour, 6.5 days on 7, and the only part change so far is the consumables, which are the tags on the ladles, and sometimes some antenna which are exposed to a ladle, hot ladle for a long time. But that's basically the maintenance.
Okay, very good. Andre is thanking for your answers. But one nice thing that I did not knew is that you, in fact, by putting the tag on the ladle, you can also monitor the usage of the ladle to check how many times he was used for treatment and how old the lining is and how long does a lining can be used. And that way you can have some more information on how to manage also the lining of your available ladles. That's also quite important for Foundry. I saw that you store the core data, you store how old the cores are, so how much time they spent waiting to be used. Is there any more information on the core shooting process that you can gather, or is only the time? So is there any data, process data like you have in the Foundry process on the core shooting process?
Yeah, it's a very good question, Victor. What I forgot to mention is every module of the tracker systems can get inputs from any device, device from any Foundry machines, so such as serial, digital, analog inputs. So, for example, the coating density, the drain time, but also the temperature and humidity of the storage room. All of that can be linked to the core ID. And also, as I mentioned, for the ladle, the chemistry, the weight, the temperature, etc.
Okay. Then we don't have any further questions. I'm also very pleased with your presentation and answers. So I think we can wrap it up. So thank you guys both for your very nice presentation and for showing us that SinterCast has developed this tracking system that will open naturally opportunities to apply the same system to other kind of alloys that are not only CGI restricted. So thank you so much for your presentation.